Hello students, welcome back to Best Academy. Today, last time we have discussed the discussion about the linear combination and definition, and we have also discussed with the help of an example to understand the definition of linear combination. In this lecture, we will discuss how the some vectors generate a space. For starting lectures, let's start today's lectures. We choose an example, show that these vectors generate space R3. To understand this example, to prove this example, whether it generate R3 space or not. Let's start it and check this space, these vectors generate R space or not. So for this, we choose this example for, so solution set will be, we say that let V1 is equal to 1 1 0, V2 equal to 1 0 1, and V3 vector is 0 1 1. Right, now we are talking to generation of R3. We will choose the scalar of R3, so we can say that here is let A1, A2 and A3 belongs to R3. So by definition of linear combination, we can written as, here is R is equal to V1 plus S is equal to V2 plus T equal to V3. We have generation of space R3. So here will be A1, A2, A3. So now we put these vector in this side, left hand side of expression. So here will be R is equal to 1 1 0 plus S equal to 1 0 1, and T is equal to, this vector is 0 1 1. Right, so here is the A1, A2 and A3. Now we're going to multiply this whole side. So if you're going to multiply by this, so R1 plus S, R plus coordinate wise, here is the term 0 and is equal to coordinate wise element is A1, and the second will be the entry R plus, here is the second R going to multiply the 0, and here is will be T, so here is A2. Right, so we're talking about the second entry, and the second entry is S plus T, and second element is basically, here is R3, so corresponding element is R3, and this is, for example, we're going to say that equation 1, and this will be equation 2, and this is equation 3, and this will be equation 4. Right, so what that is, here is basically we need to find the values of R. If you're going to say that, going to subtract this equation, subtracting equation 2 and equation 3. So by subtracting, here will be R plus S is equal to A1, and here will be R minus T is equal to A2, and the term will subtract, will be changed into the minus. Here is basically there, and here will be a sign change, and will be a cancel term. So related term will be S minus T is equal to A1 minus A2. Right, if you see that, here will be, let's suppose this is called an equation number 5 term. Right, so now we're going to subtract equation, this adding equation 4, here will be equation, for example, 5, so adding 4 and 5. If you're going to adding equation 4 and 5, you notice that here will be 2s is equal to, and this term will be add A3 plus A1 minus A2. We need to find the values of S, and here will be S is equal to, the term will become is equal to 1 by 2 terms of like this way. So the term will become, here is A3 plus A1 minus A2. Right, if for let's suppose we're going to put this value of any of the expression. We can easily find the value of t. If you're going to subtract this value, put this value in this equation too, so we can find out s is equal to, here is r plus, will become a3 plus a1 minus a2, here is equal to a1. So we can easily find out value of r. So here is basically 1 by 2. So subtracting this term, then here term will come like this way. So situation will be a1 minus this term of a3 plus a1 minus a2. So solve it. So here is divided by 2 term. So we can find out the value of r is equal to a1 minus a3 plus a2 divided by 2. So here is, you can say that, value of r. So similar case, if you're going to put this value or the value of r in equation number 2, either 2, you can say that put the value of s, we can find out the t. You put this value in equation number 3, we can find out the value of 2, t value. So substituting the values, this value in equation number 3, so we can say that s is equal to a2 minus term of is a1 minus a3 plus a2 divided by 2 term. So s is basically will become the value a2 minus a1 plus a3 divided by 2. So here is basically the value of t. See something wrong. Here is the value of t. Is the value of t. So if you're going to put these values, here is the value of, we have the value of s. Here is the value of s we have. Here is the value of r. Here is the value of t. So we're going to put this value. I'm going to remove this side to check that whether this value satisfy the equation or not. So we choose some values. We're going to remove this side to checking if it is true or not. So I'm going to remove this value. So also I'm going to remove this step. We have find out the values. Now we choose this value and put this value on your expression number 1. So here is the value is related to, here is a1 minus a3 plus a2 divided by 2. So here is 1, 1, 0 plus s term. I'm also going to remove, if I'm going to write the value of s, so here is a3 plus a1 minus a2 divided by 2. So here is r, here is, I'm going to replace the clear the space. So here will become 1, 0, 1 plus the t, the value of t, where is the value of t? Here is the value of t, a2 minus a1 plus a2. Here is the of expression. So I'm going to remove this value. So we have, here is 0, 1, 1. So here is a1, a2, a3. So this expression will be satisfied. Left hand side will be is equal to right hand side of the expression. So we can say that the given vectors, so given vectors satisfy that is left hand side is equal to right hand side. So the vectors generate in R3 space. So this is the way you can find out the expression. Basically use the definition of linear combination. If you need any space of R3, you need, for example, R2, then you take scalar A1 and A2, right? So when left hand side is equal to right hand side expression satisfy, it means that your expression is correct. It means that for scalar values, your left hand side expression is equal to right hand expression. It means that your space is 2 and you are gonna to calculation is correct. Here I'm gonna to start my lectures. If you have any sort of query, any sort of question, you give me a comment. I will discuss in next video. So till next video, bye bye.